Hello guys, myself Vikash Kumar. I'm a chemistry teacher. Today I'm going to start a physical chemistry from mole concept chapter. So watch my video carefully. Initially we will discuss about question. So question, according to question, find the number of atoms. Find the number of atoms in 48 gram of ozone at NTP. So first, what is molecular formula of ozone? So molecular formula of ozone is O3. Ozone molecule is formed by 3 atoms. So here atomicity of ozone is 3. Now what is atomicity? Atomicity means total number of atoms. It means here we can write substances, here number of atoms, after that atomicity of substances. Substances may be atoms, molecules or ions. So in case of monoatomic element we can observe here sodium, potassium and calcium. These are monoatomic elements because these 3 atoms are monoatomic elements. So number of atoms is 1, 1, 1. So atomicity is 1, 1 and 1 respectively. But in another case, for molecule like H2, total number of atoms 2, so atomicity is 2. In case of O2, total number of atoms 2, so atomicity is 2. In case of O3, ozone, total number of atoms 3, so atomicity is 3. In case of P4, we can observe phosphorus, total number of atoms 4, so atomicity is 4. Now with the help of some other example, you can take a screenshot. After that we can discuss some other examples like sulfur acid. Sulfur molecular formula acid, so number of atoms 8, atomicity become 8. Now in case of hydrogen fluoride, total number of atoms 2, hydrogen plus fluorine, so due to presence of 2 number of atoms, atomicity become 2. In case of H2O, in H2O 2 hydrogen atom and 1 oxygen atom present, so total number of atoms 3, so atomicity become 3. Now in case of H2SO4, 2 hydrogen atoms, 1 sulfur atoms and 4 oxygen atoms are present in H2SO4, so total number of atoms 4 plus 1 5, 5 plus 2 7, so total number of atoms 7, so total number of atoms 7. Now atomicity become 7. So now you can find atomicity of any substances. Now according to given question we can calculate total number of oxygen atom in 48 gram of ozone. Actually formula of number of atoms in given mass of substance in gram, then formula is given mass of substance in gram divided by molecular mass of substance in gram multiplied by Avogadro number 6.022 into 10 to the power 23 and multiplied by atomicity. So finally we can collect data and put in this formula and get result. So given mass 48 gram and molecular mass of O3 is here 16 plus 16 plus 16, so 48 gram. 48 gram molecular weight of O3 ozone multiplied by 6.022 into 10 to the power 23 into atomicity 3. So after calculation and after multiplication of 6.022 into 10 to the power 23 into 3, 18. Now after multiplication 18.066 into 10 to the power 23. So in terms of scientific notation we can write here as decimal shifted from their position. Now 1.8066 into 10 to the power 24 atoms of oxygen. So this is the answer. You can take a screenshot. Hello dear student, question number 2 is completely based on Avogadro law of gases. So according to Avogadro law, equal volume of gases contains equal number of molecules at constant temperature and pressure. Once again, at constant temperature and pressure, equal volume of gases contains equal number of molecules. So with the some experiment, we can understand easily this question. Now, whenever three different gases having same volume, whenever three different gases having same volume present in these containers, like container A, container B and container C. In A container, 1 liter, here volume of O2 is 1 liter. So 1 liter O2, 1 liter O2 gas present. Here 1 liter N2 gas present. Here 1 liter some other gas like CO2 gas present. Now volume of O2 1 liter, volume of N2 1 liter, volume of CO2 1 liter. Now at constant temperature and pressure, we can observe here volume of O2 is equal to volume of N2 is equal to volume of CO2 is equal to 1 liter. So number of moles of O2 is equal to number of moles of N2 is equal to number of moles of CO2 at constant T and T, at constant temperature and pressure. Okay, or at constant temperature and pressure. So from Avogadro's law of gases, B varies n, B is equal to Kn. Now we can remove these figures and we can observe here, according to question, what is the ratio of volumes occupied by 1 mole O2 and 1 mole N2. Now we can write here, these are the volume of gases, these are the total number of moles of gases or gaseous molecules Now from Avogadro law we can write here V1 by V2 is equal to N1 by N2. According to question, here number of N1 is equal to, N1 means number of moles of O2, then 1 mole, and N2 number of moles of O3, ozone, so also 1 mole. Now we can find ratio N1 by N2. Okay, so from this formula and from Avogadro law, we can now from Avogadro law, volume of O2 by volume of O3 is equal to number of moles of O2 by number of moles of O3. Now we can solve this question. Volume of O2 by volume of O3 is equal to 1 mole by 1 mole. So finally 1:1 is volume ratio of O2 and O3. So 1:1 is ratio of number of moles of O2 and O3. So 1:1 is correct answer. Now we can take a screenshot. Now I am going to solve question number 3. This question is based on gram atom, gram molecule and gram ion. So this question is completely based on gram molecules. So watch my video carefully. Now calculate the mass of 5 mole of CaCO3 in gram. According to this question, calculate the mass of 5 mole of CaCO3 in grams. What is mass of CaCO3 of 5 moles of CaCO3 now? So here mass of 1 mole of a molecule means molecular mass of a molecule in gram. So you can check here mass of 1 mole of CaCO3 molecule is CaCO3 molecular mass Ca plus C plus O plus O plus O. So 40 plus 12 plus 16 plus 16 plus 16. So after addition total 100 gram. So here 100 gram is molecular mass of 1 mole of CaCO3. Now from question, mass of 1 mole of CaCO3 is 100 gram. Now mass of 5 moles of CaCO3 molecule, 5 into 100 gram. Now 500 gram. So 500 gram is answer. Now we can take a screenshot. This question is based on calculation of volume. So according to this question, the vapor density of a gas is 11.2. Calculate the volume occupied by 11.2 gram of gas at NTP. According to this question, at NTP, how much volume occupied by 11.2 gram of gas having vapor density 11.2? So first we can solve this question. Here given vapor density 11.2, so molecular mass of gas is 2 into vapor density. So 2 multiplied by 11.2. Now 22.4 gram is molecular mass and 22.4 gram per mole is molar mass. Now here we can find easily number of moles. Now number of moles of gases is given mass given mass of gas in gram divided by their molar mass of gas in gram per mole. Now according to given data we can put here given mass is 11.2, so 11.2 gram divided by molar mass is 22.4 gram per mole. Now here 1 by 2 mole is number of moles of gases. So here number of moles of gases, you can take a screenshot, 1.2. Now we can calculate here total volume occupied. So volume of gas is equal to number of moles of gases multiplied by molar volume of gas. Number of moles is half and molar volume is 22.4 liter at NTP. So after calculation 11.2 liter is answer. You can take a screenshot. Now this question is question number 5. This question is completely based on number of atoms in given mole of molecules. So according to question, calculate the number of oxygen atoms in 0.2 mole of Na2CO3, 10 mole of H2. So this is the hydrate of sodium carbonate. Now from formula, the formula is number of atoms in given moles of molecule. Number of atoms in given mole of molecule is equal to number of moles of molecule multiplied by Avogadro number and multiplied by atomicity of atom C molecule. Now according to question, the molecule is Na2CO3 10 mole of H2O. Here number of oxygen atom 3 and plus 10. So 13 oxygen atom is present here. Now you can take a screenshot. So here atomicity is 13. Now from question, number of oxygen atoms in 0.2 mole of Na2CO3 and H2O is equal to, here number of moles is 0.2 mole, 0.2 mole, and multiplied by Avogadro number 6.022 into 10 to the power 23 and multiplied by atomicity. So atomicity is 10 oxygen plus 3 oxygen, 13 oxygen atoms. Now after calculation, 1.56 into 10 to the power 24 atoms of oxygen is answer. So you can take a screenshot right now. Now this question is question number 6. According to this question, calculate the number of moles of CuSO4 contained in 100 ml of 1 mole per liter CuSO4 solution. This is question number first. Also find the number of sulfate ion in it. According to this question, first we will calculate the number of moles of CuSO4 contained 100 ml. So according to this question, now 1 mole, here molarity is 1 capital M. So 1 mole per liter, 1 mole per liter. Now given volume is 100 ml. So volume in liter, 100 ml divided by 1000 ml and transform into liter. So 1 by 10 liter. So 0.1 liter is here. Now we can find easily number of moles of CuSO4. Now molarity, mole by liter multiplied by volume in liter. Now we can find here by the putting these data's number of moles of CuSO4. So molarity is here 1 mole per liter. So 1 mole per liter and multiplied by volume is 0.1. So 0.1 liter is here. So after multiplication, here 0.1 mole is number of moles of CuSO4. Okay. So 0.1 mole is correct answer. You can take a screenshot. After that, we can solve another part of question. Now we can find number of sulfate ions. Number of sulfate ions in 0.1 moles of CuSO. 0.1 into 6.022 into 10 to the power 23 ions. Now divide by 10, decimal remove from here, and now 6.022 into 10 to the power 22 ions. Now in terms of 0.6022 into 10 to the power 23 ions of sulfate is present here. So question is finished right now. So this is the answer. Now question number 7 is based on calculation of nucleons. So what is nucleons? Nucleons is those part of atom, those central part of atom, those part of nucleus in which total number of protons and neutrons are present. So nucleons is always equal to total mass number. So according to this question, find the total number of nucleons present in 12 gram of C12 atoms. So number of nucleons in C12 is 12. Okay, but according to given data, number of atoms of C12 in 12 gram. Now given mass is 12 gram and divided by 12 gram atomic mass and multiplied by 6.022 into 10 to the power 23. So after calculation, 6.022 into 10 to the power 23 atoms of carbon is present here. So number of nucleons is already equal to mass number. So number of nucleons is 12. Now total number of nucleons in 12 gram of C12 is number of nucleons per atom and multiplied by number of atoms. Now number of nucleons is equal to mass number 12. So 12 multiplied by number of atoms, 6.022 into 10 to the power 23. So we can calculate. Otherwise here this is answer. So you can take a screenshot. Now the next question is question number 8. According to question number 8, find the total number of neutrons. In 7 milligram of carbon 14. And according to this question, total mass of neutron is 7 milligram of carbon 14. So now number of neutrons is what in carbon 14? Neutrons is 14 minus 6 is equal to 8 in carbon 14. So here neutron is 8. Now we can find here neutron is 8. Now first question we can solve here. The total number of neutrons in 7 milligram of carbon 14. Now 7 milligram by atomic mass of carbon is 14 gram multiplied by 6.022 into 10 to the power 23 into 8 neutrons. So 7 into 10 to the power minus 3 milligram transform into 10 into gram divided by 14 gram multiplied by 6.022 into 10 to the power 23 multiplied by 8. Now after calculation 1 by 2 is here, 2 4 ja 8. Now 4 multiplied by 6.022 into 10 to the power 23, okay, into 10 to the power minus 3. Now we can observe here 4 into 6, okay. So after multiplication we can observe here result 2 4 ja 8, 2 4 ja 8, 0 0 for the 0 and after decimal 24. So 24.088 into 10 to the power 20 neutrons. So this is answer. You can take a screenshot. Now with the help of calculation of number of neutrons, so total number of neutrons is here, we can solve question number 2. So according to question number 2, total mass of neutron, total mass of neutrons in 7 milligram of carbon 14. So here formula is total number of atoms multiplied by value of 1 AMU. So what is value of AMU? 1 AMU is 1 by 6.022 into 10 to the power 23 gram. Then 1.66 into 10 to the power minus 24 gram. This is the value of 1 AMU. So you can write. After that, after putting these values, we can get answer. So total number of atoms is here 24.088 into 10 to the power 20 multiplied by value of 1 mu 1.66 into 10 to the power minus 24 minus 24. Now here we can put here gram because unit of AMU is gram. Now after calculation we can observe here 4 into 10 to the power minus 3 gram. Now this is answer. After that we can transform into 0.004 gram. So this is another answer. You can take a screenshot. Now I am going to solve question number 9. According to question number 9, how many moles are there in 1 meter cube or meter cube of any gas at NTP? Now volume, given volume is 1 meter cube is equal to 10 to the power 3 liter, or 1 meter cube is equal to 1000 liter. So here volume is 1000 liter. Now according to question, how many moles are there? So number of moles of gases at NTP in given volume of gas is equal to 42 given volume in liter divided by 22.4 liter per mole. So after putting these data we can calculate given volume is 1000, so 1000 liter divided by 22.4 liter per mole. Now after division 44.6 mole. This is the answer. You can take a screenshot. Now I am going to solve question number 10. This question is based on calculation of molality. So according to this question, 3 gram of salt of molecular weight 30 gram or 30 is dissolved in 250 gram of water. Calculate the molality of solution. What is molality? Molality is a unit of concentration and molality is expressed in mole per kg. How we can find molality? The formula of molality is total number of moles of solute divided by total weight of solution in kg. So unit of molality is mole per kg. Now molality denoted by small m, mole by kg. Here formula is total, or here formula is here formula is number of moles of solute divided by total mass of solution in kg. Now according to given data we can find number of moles of solute. Given mass is 3 gram divided by molar weight. Here molecular weight is 30, so molar weight is 30 gram per mole. Now divided by total weight of solution, here 250 gram weight of solution. Now we can transform or convert gram into kilogram, so divided by 1000. Now 250 by 1000 kg total weight of solution. Now after calculation, 3 1 3 times 30, so 1 by 10 is here. Now 0 cancel by 0, 25 1 25, 25 4 100, so 1 by 4 is here. Now 1 by 10 multiplied by 4 by 1. Now 4 by 10. So 4 by 10 we can write 0.4 a small m, or 0.4 mole per kg. So 0.4 mole per kg or a small m is unit of molality. So you can take a screenshot. Question is solved right now.